All right, chemistry students, back again. So, where I cut off in the last video was explaining this little chart, that moles is our bridge between molecules and grams of a substance. We have a conversion factor between moles and molecules, which is that 1 mole equals 6.02 times 10 to the 23rd molecules. And we have a conversion factor between moles and grams of a substance, and that 1 mole of any substance is equal to its atomic mass on the periodic table. And we can use that to figure out from how many grams of a substance we have weighed out how many molecules that contains. And if we know the number of molecules, we can figure out the mass of that number of molecules. But in order to do that, we have to step through moles. Moles is like our bridge. We cannot go directly between molecules and grams. That's sort of what this chart on your homework was trying to tell you. And what we're going to do together is I'm going to walk you through a few of your homework problems so that we can I can show you the overall process here and how this works. So the first question is, how many moles are there in 24.0 grams of iron 3 fluoride? So if we want to convert between grams and moles, we know that 1 mole is equal to the atomic mass of that substance in grams. So first we need to figure out what is the atomic mass of iron 3 chloride. Well, if we look at our periodic table, 1 iron is equal to approximately 55.8 grams. And we have 3 fluorines. Each fluorine is equal to approximately 19 grams, 18.99. So 1 fluorine is equal to 19 grams, and we have 3 of them, so we'll say plus 3 times 19. So the atomic mass of iron 3 fluoride would be 55.8 plus 3 times 19, which gives us 112.8 grams. So what this means is that 1 molecule of iron 3 chloride is equal to 112.8 AMU, and therefore 1 mole of iron 3 fluoride would weigh 112.8 grams. So if we have 24.0 grams, we can set this up in a railroad diagram and say, okay, well, I need the grams to cancel out, I need to create moles. So grams is going to go down here, and moles is going to go up here. And from what we figured out earlier in the year, as long as the top and bottom cells are equivalent, then that's a conversion that we can do. And we have an equivalency here. 112.8 grams is equal to 1 mole. So 1 mole of FeF3 is equal to 112.8 grams of FeF3. Grams will cancel, and that will leave us in moles. So by this railroad diagram, we multiply anything that's on the top and we divide anything that's on the bottom. So we'll just put that back into our calculator. We'll do 24 divided by 112.8, and that gives us 0.213 moles. And that's our answer. And if we check that against our key, it should give us something similar, maybe a little bit different off of rounding, but no, that agrees exactly with what's on the key, 0.213 moles. So let's do one more shot at a problem that's slightly more complicated. Let's take a look at number 3. So this question is asking, how many grams are there in this many atoms of silver? Now, we have a huge number of atoms of silver, and we need to convert between grams and atoms. So if we look at our chart, this is where we have a problem. We can't go directly between grams and molecules, or grams and atoms in this case. We can't go directly there, but we can figure out, okay, I have a certain number of atoms, and I can convert that to moles. And then if I can convert that to moles, I can convert that to grams much in the same way I did this problem. I would just need to do it in 2 steps. So, as we saw here, moles to grams or grams to moles is a 1-step process. And in the same way, moles to atoms or atoms to moles is a 1-step process. If you're going from molecules or atoms all the way to grams, that is a 2-step process. We need to convert to moles first and then to grams. So let's see how we would do that. We know automatically that 1 mole of anything is equal to 6.02 times 10 to the 23rd of that thing. So 1 mole of silver atoms is 6.02 times 10 to the 23rd silver atoms. And then we also know that 1 mole of silver will weigh a certain amount. We know what amount that is because it's the same weight that's on the periodic table. A mole of silver atoms is equal to its atomic mass from the periodic table in grams. So 1 silver atom weighs 107.86 grams. 1 silver atom weighs 107.86 AMU. Therefore, a mole of silver atoms would weigh 107.86 grams exactly. So, 1 mole of silver weighs 107.86 grams. So, we can set up a railroad diagram to convert 1 step at a time from atoms to grams. So let's do that. We write down what we know. We have 2.30 times 10 to the 24th atoms of Ag. We'll convert from atoms, not to grams, but to moles first. Because we know that 1 mole is equal to 6.02 times 10 to the 23rd atoms. So 1 mole equals 6.02 times 10 to the 23rd. That will cancel out atoms. If we stop the problem right here, that would tell us how many moles of silver are in this many silver atoms. But we don't want that. We want the number of grams. So we'll do one more step and convert out of moles and into grams. Well, again, we know we need to write something that's equivalent in the top and bottom cells, and we know that 1 mole is equal to 107.86 grams of silver, which is its atomic mass from the periodic table. So we've set up our railroad diagram. Moles will cancel, atoms will cancel, we'll be left with grams, which is what the problem asked for. We multiply everything on the top, we divide everything on the bottom. So we would put that into our calculator as, need to go scientific, 2.3 times 10 to the 24th divided by 6.02 times 10 to the 23rd, and that tells us the number of moles. Again, if we stopped here, that'd be 3.8. We have 3.8 moles of silver. And then we would have to multiply times 107.86 times 107.86 gives us 412, and the answer equals 412 grams of silver, rounding to 3 significant figures, which is the same number of significant figures that we have here. So if we look at our answer sheet, that should be approximately what we have. And in fact, it is. The answer to number 3 is 412 grams. So that is how you do this type of problem. You set up a railroad diagram, and then you follow the railroad diagram, canceling units at each step until you get to your final answer. Again, one thing that students seem to struggle with in setting up the railroad diagram isn't the setup, it's actually doing the work. So, again, to refresh, this setup tells us that we take 2.3 times 10 to the 24th, we divide by 6.02 times 10 to the 23rd, and then we multiply by 107.86. We put that into our calculator each step all the way down the line until we are done. All right, that's all I have for you. This is about the most complicated type of problem that you'll see. Anyone that asks you to convert from grams to atoms or from atoms to grams will follow this two-step process, but that's really all that it is. The two-step process is about as far as we'll go for now. We'll add a little bit onto that in a minute, and we'll probably finish up with that by the end of the week, combining this stuff with chemical equations. So I hope that was enlightening. Let me know if it helped. Hopefully you should be able to finish all of this work using the setups that I've given you. Thank you very much. Thank you for tuning in. Have a good day.